All right, everyone. So now we know what a one-way ANOVA is, how to run our one-way ANOVA analysis in SAS/JMP. Now what we need to do is figure out how to graph this one-way ANOVA so that we can show our results to the public. So we'll start doing this by going with our original data sheet, which I showed you earlier. We're going to go up to Tables and then Summary. And I showed you this in another video, but basically what we want to do is group our statistics by our independent variable, so population. And of course, this is just grouping based on the category of the 4 populations. So to graph our figures, what we're interested in are 2 statistics. First is the mean, and second is standard error. So the mean we've already talked about. It's just the average of the observations within each group. The standard error, however, is a measure of how spread out the data are around the mean. So this is why, although these means that we got on our analysis may look different, especially the Portland, Tillamook, and Newport, they may have different numbers for the means. They aren't truly different because they have overlapping standard errors. So the spread of the data around the mean are overlapping. Okay, but how do we find mean and standard error in a way that we can easily graph it? We move our group, our population, down into group. Then we highlight our dependent variable, which is shell length. Click the statistics drop-down button. And the first thing we want to look at is mean, so we'll click mean. And as you can see, we're looking at the mean of, let me see if I can make this bigger, mean of shell length. And we're going to do the exact same thing for standard error, and that's STD-ERR. Okay, so that's going to give us the mean and standard error of each one of these groups. And we'll push OK, and we'll get another chart that pops up from there. So this has each one of our 4 populations, the number of rows, which we're not super interested in, the mean of each population, and the standard error. Now, in order to graph that, we want to open an Excel file. So I'm opening a clean Excel workbook. And what we want to do, on one row, we want to type in all 4 population names, or all 4 groups. So we have Newport, we have Petersburg, we have Portland with a D, and we have Tillamook. All right. Now, it may seem kind of silly right now, but what you want to do is copy that row. So copy it and paste it a little further down the data sheet. And I'll explain why in a bit. All right, so in this first section, we're going to call this the means, and we're going to call this one standard error. So what we don't want to do is copy each one of these means into their respective parts in Excel. So the Newport will simply copy. Same with Petersburg, Portland, and Tillamook. All right. Now we're going to do the same thing with these standard errors in the same order. So we have our Newport, and you'll notice that these standard errors are all different. We'll paste that. And I'm copying and pasting because it's a lot quicker and more accurate than trying to hand type in these long standard errors. You're very likely to make a mistake, at least I am. So I copy and paste. All right, so now we have our means and our standard errors from our analysis into an Excel file. So the first thing we're going to do is simply highlight our first set of rows, and we want to include the population names as well as their respective means. We'll then go to Charts, to Column, and to Clustered Column. All right. right, and that's going to plot our means for us. Now, just a few formatting things. We can take this series, just click on it and remove that. And we can also take these horizontal lines off to make us have a little bit of a better looking figure. All right, the next thing we need to do is add our X and Y axis labels. So to do that, we go up to Chart Layout, Axis Titles, and we'll start with our X-axis. And we go to Title below Axis. And what is this? This is our populations, right? These are our populations. So we'll label it accordingly. And we'll do the same thing for our x-axis, vertical axis. And I always do rotated title because it just tends to look better. And this is shell length, I think, correct? Yeah, shell length. And that's going to be in centimeters, so I'm going to put the appropriate units. Okay, we have plotted our means. We know our x and y axis, what they mean. The next thing we need to do is put our standard error bars on our figure. So in order to do that, we're going to click on the histogram on the blue bars, and we're going to go to Chart Layout, Error Bars, and Error Bar Options. Now we want to go down to Custom because we have custom error values that we want to put in. So we're going to go to Custom, Specify Value, and it'll come up with this window. What you want to do is click on this little grid pattern to the right of the window, and we're going to highlight all of the standard error values, so all 4 of them. Then we'll click on that grid again. And our negative error values are the same as our positive error values. So again, we'll click on the grid and we'll select all 4 of these cells. Okay, and we'll push OK. And we'll push OK again. And that gives us our standard error bars on each one of our means. And again, standard error is simply the measure of how spread out the data are around the mean. Now, one thing that strikes me with this figure before we move on is the fact that we have a lot of wasted space down here between 0 and 6 centimeters of shell length, because we see that all of the populations had shell lengths over 6 centimeters. So what I like to do is double click on this y-axis, and I go to minimum, and I put in 6, for example, and push OK. And what that does is it lets us see the bigger differences among means because we're getting rid of that lower section of the figure that's the same for all populations. So don't forget that we did, with this One-Way Anova, an a posteriori test. So we did a test that will tell us exactly which means are different from the others. And again, that was found on the bottom right-hand portion of our SAS/Jump output. And we saw that Petersburg was the only one that was different from the other 3. So we want to show that on our figure. We want to show people, even though it's really obvious based on the standard error bars, because this standard error bar doesn't overlap any of these, but we want to show with that a posteriori test as well. So we'll go to Chart Layout again, we'll go to Data Labels, and then we'll go to Outside End. So right now, these numbers consist of the mean for each group. All you have to do is move that box up and erase the mean, and just add in the letters you got from your a posteriori test. So, for Newport, Portland, and Tillamook, we had the letter B, and that indicates that none of these differed from the other. So we're going to incorporate that. But then on our Petersburg population, we saw that it in fact was different than the others. So we label that with an A. And this just shows people that this population was greater, the size was greater than these other three, and these other three did not differ. So that's a very simple way to highlight your data into a nice looking chart. You can always change the formatting of this chart. For example, with these axis labels, I typically like to make them bigger, perhaps size 16 and bold. And I'll do the same with this one. And I also like my axis labels to be larger. So I can double click on these numeric values, and I can go to font, and I can increase that size, perhaps 14. And same down here with the populations. I can click on these populations and increase that font size to 14 as well. And that just makes it a little easier to read. Same with these. You can easily click on them, move them up to perhaps a 12-point font. So that is how you graph One-Way Anova in Excel. If you have any questions, please feel free to ask your HSTA mentor or your instructors. Thank you.